Okay, so welcome to the second session on contact in Marc. So Marc is Marc Nastran. A lot of it is the same. As things differ between the two, I'll just mention them briefly. Okay, so this is just the entrance slide that I had last time as well, just to show where we're going. So if we go to the next page, what we covered in the first one was contact algorithms, what it is, why it's needed, the basics of contact in Nastran and Marc. And in that, we briefly looked at contact bodies and so on. In this section, we'll spend time on the contact table or contact body pairs. Just briefly, Marc tend to use the contact table. Contact body pairs is simply a different way to look at the contact table. In Nastran, it differs a bit. You can either use a contact table or body pairs. And then I mark it in yellow, the additional stuff, contact interactions, other settings, because we'll just start touching on them, but it's way too much to spend a lot of time on those in this session. So this will be discussed then in the next section. Stuff in gray are things to do with contact that we'll still look at later on in the series. Okay, so just to briefly recap, I'll do this really fast. The last one is spend time on contact bodies. In other words, different types, whether it's shells or solids or beams, all of them can be used as contact bodies. All of them can be used in one analysis. We can just not have solids and shells in the same contact body, but I can do this as two separate contact bodies, for example. Same goes, we can use first and second order elements in contact, no problems there. Again, in one contact body, you can only have first or second order elements. And then the last type that we looked at was geometric bodies. In other words, typically a surface, a three-dimensional surface, complex surface, can be cylindrical, spherical, or any kind of a complex surface that's available. Okay, we also spend a bit of time on smooth contact. That's where the software fits splines through the contact bodies to make contact against smoother regions. It's a way to get past issues with first order elements and the discrete contact, that discrete meshing that we end up with. Okay, then the two most important parameters for contact detection, the distance tolerance and the bias factor. We spent a bit of time on those, went through some examples of why they work together and what to change and when, if you have what kind of behavior, something arguments like not making contact, that should, what should you change between these two? Then we also spend a bit of time on separation. So when there's a tensile force or stress, a node in contact should effectively separate. And then the last one, glued contact, was about the ability to not separate. So it's to connect dissimilar meshes. It doesn't separate, it doesn't slide. So effectively infinite friction as well. Okay, so that's just a recap of what we did last time. Okay, in this section, we'll start looking at contact table or contact pair. So the intent is the same. So I'll treat it as if it's the same. Where there's differences, it's more in how it's implemented than anything else, but the intent is exactly the same. So why do we need a contact table? If you do not have a contact table in Nastran or Marc, let's say you've specified all your contact bodies. If you don't have a contact body, all bodies can touch all other bodies, including self-contact, but it uses default settings. And that's the important bit. In a lot of analysis, I want very specific settings between different parts. Okay, in other words, if I use defaults, I cannot have glue, I can't have friction, I can't override per body pair certain settings in terms of distance tolerances or bias or anything. Okay, so the purpose of the contact table is to define how all of my contact bodies in my analysis can interact. The moment I add a contact table, I have to define it for every pair of bodies, all body pairs, not just the ones I want to change. Okay, so some examples of what we can do with a contact table that's not possible to do without it is glue contact, interference fits. I'm not talking about meshes that overlaps, but there's special interference methods available. Projection settings, what should happen to nodes that penetrate slightly or are close to the surface, should it be projected? How should it be projected? How far should it be projected, and so on. And the same for overriding the default contact tolerance or bias per pair of bodies. So these we can change per contact body pair. If I have 10 contact bodies, but I only want to change it for one pair, I can do this in the contact table. Okay, so let's start with an example. This is a pretty nice, very simple model with already quite a lot of contact bodies. Okay, so you've got two L brackets, some kind of a plate, a lug, and then I've got what you don't see on the other side. I've got a bolt going through, a washer on the bottom, a washer on the top, and a nut. And the way I want to connect this argument's sake is, let's for the simple sake say, I want touching contact between most of these, but some exceptions are these I want to glue together. There's a weld that I haven't modeled that I want to include effectively. And I want to glue the nut onto the bolt. Okay, so in this case, I've imported the model, set up all the contact bodies, and I gave them names that hopefully make sense. If I look at, for example, the washer at the bottom of one, this happens to be number one. It doesn't really matter which one, but I chose it so that that'll be the top washer one and the bottom one will be called washer bottom number one, and the bolt one and the nut one and so on. Okay, so any names would have done, would have worked. This is just to make it a bit easier. Now we get to the contact table, and as you can see, it's pretty large. If I look at this, if you haven't ever seen a contact table, if I look at this section with nothing in, all of those mean there's no possible contact between those. So if I just go back, the lug against the lug, because it's the first body against the first body. If I go back, it doesn't make sense for that part to make contact to itself, but that one and that one should make contact. So let's see if that's the case. The lug against that was the plate. Plate is number 18. So lug against plate, so 18 has a G in. G means glued, T means touching. So those are the important ones. So as it's set up there, I used a method to automatically fill this in based on distances, but I haven't checked. I know there's actually some that was missed because my distance for the contact was actually slightly too small, so some weren't picked up. I just changed a couple of these to glued contact as well to say, for example, the nut for the bolt set number one should be glued to part number 5, which is the bolt. So those are glued together. And there, again, the same, the nut for number 2 and the bolt for number 2, and so on. Okay. Now, if I look at the same in Mentat, I just switched the view from table view to entry list, which is this is more or less our Nastran's body pairs work, where you specify one body and which other body, and then you have settings that you can fill in. This is just a simplified view of that, so you don't see all the settings. Now, note already there's a contact interaction there, which says which interaction is being used. We will talk about interactions a bit later on. So for the moment, just take note of it, but we're not yet discussing it. Okay, so we need solutions for these kinds of models where we have lots and lots of contact body. So let's first describe the problem. We end up with either a massive contact table or lots of contact pairs, depending on which method I've chosen. Again, in Mentat, it doesn't really matter, it's the same thing. So if I go back to this one, if I just had one contact body, this would have been a 1-by-1 matrix. If I have two, it's 2-by-2. So every time I increase it by 1, it's the square of that number, and that's the total number of entries. And you have to check all of these to say, does the lug touch itself? Does the lug touch this? And what I've done here is I've actually slightly cheated, because in Mentat it only shows 15 at a time. So then you have to switch to, let's say, the first 15 here, but the last 5 there in a separate section, simply because the contact table becomes too large. So it makes it manageable, but it makes it even worse in terms of trying to find out what this is. In other words, what can contact what? Now, there are a couple of ways to, even on a large model like this, simplify to say, I only want to see these bodies. Fine, then it's a lot easier to set up, but it's not the only solution. Okay, so there are methods. There is a setting that you can simply say auto detect the bodies and activate the contact between them. It's a really good way to initially set up the pairs that's close together, but we still need to verify that we haven't missed anything. So I think the easiest will be, let's see if I can get a model up quickly. Can you see me entered now? Okay, so I'll import that same model. So pattern file. Okay, so now I have a mesh. I just want to clean this up. I don't want any of the geometry. I want it as clean as possible. I don't need a job. And I can delete all of the sets. There's just some of the stuff that came across together with that file. So effectively what I have is simply this mesh. And now to create that contact set of elements as before, I can go to the contact and simply say detect mesh bodies. If I now identify, I'll see all of them, 20 bodies of them. What it does is it'll randomly pick, let's say, that node, and then it says, okay, let's see what elements are directly or indirectly connected. So it floods all of these and it creates a contact body. Then it tries another node, until it finds all of these. So I can in my tree go and say body one, let's say what it is. Easiest to simply deactivate it. I'll call that the lug. So just open it up and call it lug and create each change both in the tree and there. But as you can see, that's a lot of work. Now I've got this model already changed, so I can show you everything already completed. Okay, now let me just minimize that for the moment. So the alternative way to reduce the number of contact entries or make it easier to view is to simply reduce the number of contact bodies. So in the previous section, we spoke about a contact body is not just a set of elements that form part of one single part. It's simply a set of elements. So it does not need to be connected. It doesn't even create any connection between them. The sole purpose is to define which elements can make contact. So if I look at this again, I can do something like, bear in mind, in my contact table, I want to specify settings between parts. So if I look at this washer to the green part, that washer to the green part, this washer to the green part, I want the same settings. Whether it's glued or touching, the friction coefficient, all of those should be the same. So there's no reason to have all of those washers different contact bodies. So I can combine them into one. I can at the same time combine all of the washers at the bottom and call it the same washer because, well, this one will touch the green part, but the bottom one will simply touch the orange part. Again, the same settings. It's the same materials, same quality of work, whether it's of the surface finish. So the friction coefficients should be the same. If I want the top one glued, I'll probably want the bottom one glued. If I want the top one touching rather, I want the bottom one touching as well. So I can simplify this. If I do the same, I can say this is probably the simplest one that makes sense. In theory, I could actually say, well, everything one contact body, but then I can't have glued there and glued between the bolts and nuts and touching everywhere else. So if I really want to do it, I can probably split it into 2 or 3 bodies then to say, but glued between these, it's a pain. So it's easier to, in terms of functionality of the functional use of something, define a contact body. So in this case, I've lumped all of the nuts into one, all of the bolts into one contact body, both of the L brackets, one body, that plate, and that lug over there. So now it's 1, 2, 3, 4, 5, 6. Previously at 20. So it's about a third of the contact bodies, which sounds not that much less. But in the end, bear in mind the contact table was squared. So this is my new contact table now. And this is just for convenience that I've added it. Now we can quickly look at all of these and say, okay, the lug can touch only the plate. So let's see, plate was number 6. sorry, number 5. So the lug is glued to number 5. I'm happy with that. Nothing else. There's nothing else on that line, so it's okay. I look at the washers. The washers is touching both the nuts and the L bracket. So let's see, the washers touch number 3 and 4, which is the nuts and the bolts. Bear in mind on the other side, we've got the bolt. And in addition, we've got part number 6, which is the brackets. I'm going to do the same for the nuts. The nuts are touching the washers and is glued to the bolts. So touch and glue, doesn't touch anything else. Bolts can touch the washers. It can touch all 3 of these parts. If you look at that center, they're all there. So the bolts can touch the washers. It can touch the plate, and it can touch the L bracket, and it's glued to the nut. And the plate again is glued to the first one. So it's the lug. It can touch number 4, which is the bolts. Touch the orange parts, the L brackets as well. Okay, and then the last one, L brackets, it touches number 2, which is the washers. That's correct. It touches the yellow part, which is number 5 there, and number 4, it touches the bolt. Again, if there's sideways movement on that part. So what I've just done was a bit of a bit long section, kind of, in terms of discussing all of this, but we just went through the whole contact table, which if I look at the previous contact table, I'm pretty certain I've actually missed some. And over there, it would have taken forever to go through everything. Just for reference, this is what the, let's say the body pair view would have looked like. The lug against the plate with certain settings. So it's a lot simpler to do this. Now again, let's briefly look at how I can combine these. So if I go to selection control, and I have to find all of these washers, it'll be a bit of a pain, so I can do stuff like this and switch stuff on and off, or I can simply say for my selection method, flood, I say elements, and then it asks me for a flood node. So I say these. Okay, so instead of doing this, let's clear this quickly and delete all of the contact bodies. Now I want to create them from scratch. I can just as well find one, rename it, and add it over there, but let's just show. If I create a contact body, I'll just do 1 or 2, contact, new meshed body, and we'll call this washers. Okay, so now I can say select the, sorry, clear that. Those, and the ones on the other side. Okay, and I add the selection. Okay, I can clear this, and I see these are part of that contact body. Okay, and to make it even easier to select the next stuff, I can simply deactivate it so it's hidden now. So it's easier to select the next ones. So I'm not going to go do the rest, but it's, as you can see, it's a pretty easy way to do this. The alternative would have been to detect mesh bodies, but then, okay, let's delete the washer. Just want to show this quickly. Delete it, and we'll do this again. So assuming we've already named them and know which one is which, I can, sorry, I just need to clear this. Okay, so I can now go on that same selection form, select control, I can select the contact bodies and say I want to select body 1, body 2, 3, 4, whatever. Once I know what they are, now they're selected, and I can add them again to one of the existing contact bodies. And then you just delete the ones you're not using at the end. Okay, so if I just open the, so this is what it would have looked like. Sorry, I've got the wrong model. Give me a second. Okay, so that's what it looks like after you've done that and gave them sensible names. Okay, in terms of the contact table, if I open that up again, so this is exactly what we've just seen in the presentation. So we'll get back to this in a second. Okay, so just to show you how to get to this view, if I go from entry matrix to entry list, I see this kind of a view. Okay. So now let's start opening one of these entries and see what's happening inside. I pick on, let's say this is the washer and nuts. So washers against nuts, so it's that one. I just click on that one and this form opens. So this one says the settings between these two, which I know there is touching, but there it's not because of that. That's just the name I gave the interaction. So we've got an interaction that defines some settings, and part of that is that interaction is a touching one, and you'll see that in a second. So apart from the interaction, we also have additional settings that has contact detection, the method, the boundary redefinition, initial gaps and overlaps, and so on. So let's get back to that in a second. So the next thing is we now open an interaction. So I edit that, and this is what I'll see. So by looking at this, you can see this is where we can redefine the contact tolerances and bias for this pair. So if you have, for example, so in this case, for all of those touching ones, I use the same interaction. So the reason for that is actually simple. So why would I want to do this? Why not just define everything on the contact table settings between the bodies? And the reason is, in a lot of cases, you want to use exactly the same settings for 90% of the model. So instead of setting this up for everyone the same, what we rather do is we create an interaction, and there we set the settings. And for those that's different, we just create a new interaction with the settings that's required for that specific pair. Now, the option for touching contact, there you see its contact type is touching. So I can switch it if I at some point realize it should have been glued. I can just change the interaction. So the tolerance and the bias I can change here. This means just for this pair, or rather for everything that uses this specific interaction, the setting will be changed. All the others will still be default unless I override those again with that interaction. The settings for expanding the section for contact segments. So that has to do with node to segment, specifically nodes that can sometimes slide past each other. Don't worry about it if you don't know what it is. All of the settings in here is what we'll discuss in a future session. Okay, we can also specify that touching. Augmentation has to do with segment to segment methods. So both node to segment and segment to segment settings is defined in the interaction. Okay, additional stuff that we can define there is if I don't want to do weird calculations or weird separation requirements. In other words, I may say it should allow a certain tensile stress, but only then separate. So it's not something we use often. Same goes for wear. You can calculate it, but you need to know the wear properties. The most important one is probably friction. So why do we define friction here and not as part of the contact body? Because friction is not a function of a material or a part. Friction is a function of two materials touching. The classic example is Teflon and steel. If I look at steel, the friction coefficient may be something like, argument's sake, 0.1. If I touch another part of another steel component, if I look at Teflon on Teflon, that's, let's say, 0.01. But Teflon on steel is also the same as Teflon on Teflon, so it's still 0.01. In other words, friction is a function of two materials touching, not just one. Okay, so in the model that we've looked at, this bolted connection, since it's the same material connected to, well, the same material mostly, again, it's convenient to define a friction coefficient for specific pairs. Okay. So these are the settings that tend to be set for a subset of an element. So it's stuff that a large part of the model, you'll have this kind of settings. So that's why we set that on the interaction. But there's also some settings to do with the contact detection method. Default simply says we'll check the first body against the second, so the nose of this against the faces of this one. And then we'll do the reverse as well, which we'll check the nose of the nuts against the washers as well. But we can change it to say, I only want to check the first one's nose against the second one's faces, or the other way around. Now, to be honest, that's something I almost always use. So it's a lot safer to tell Marc the direction of contact you want to check in. It simply improves, in most cases, the quality of the contact result, but it also makes it a lot simpler to visualize and to understand what is happening in the body pairs. Okay, we can also redefine behavior of what the bodies look like. If I look at the shell, by default, shell elements make contact on the outer faces, as we've discussed in the first session. I can redefine this to say, let's say the first one was shell elements. I can redefine that and say make contact with this one on the mid plane and top, or mid plane and bottom. And I can do that separately for the two contact bodies. This first refers to that first body, and that second refers to the second body. Okay, then there's options for initial gaps and overlaps and interference fits. It's methods to make contact either slightly before or allow a little bit of overlap between meshes without generating a stress, or the opposite, to cause a stress by forcing nodes open, for example, or meshes that's in contact. Okay, so the two are not exactly the same, but they share a lot of commonality. We'll discuss the difference between them at a later stage then. And then there's a setting that says, well, if I have, for example, two meshes making contact, one fine and one coarse, by default, or the ideal situation with the fine mesh makes contact to the coarse mesh. We'll discuss why a bit later on, so don't worry too much about it. But the second requirement is you rather want the lower stiffness material touching the higher stiffness. So in other words, if I've got a rubber and steel, I want the rubber to touch the steel. And there's automatic methods to figure out, instead of the default, which simply says check this against this and then the reverse, there's a method that says try and automatically guess the sensible direction. And this is a setting that simply says, well, if the one mesh is finer than the other, but we also have, let's say, so the rubber is the coarse mesh. Ideally want the steel then to touch the rubber, but the rubber has got lower stiffness. So at a ratio of about 2:1 in terms of elastic modulus, it should then rather make contact from the rubber to the steel. To be honest, I don't use the automatic setting, and even in that case, it's better to rather remesh the rubber so that it matches both. So the rubber is the finer mesh and the lower stiffness, which makes sense. So that's a bit of a divergence from what I'm trying to do here, but this is the important, but it's the kind of settings that I can change on this form. So these settings, not interaction, these settings are stuff that's very often set for very specific bodies, different to everything else, while the interaction stuff are those that you tend to set for a lot of bodies to be either the same or almost exactly the same. Okay, then the next screen is the same as before. It's still, I'm looking at interaction. I've just picked a different one that used the glue interaction. So these settings didn't change. The interaction form changed. If I look at this, there it says glued contact, and you can see there's quite a few additional options. So we still have the distance tolerances, tangential extension, project stress free, and so on. But we have additional settings that says for shells glued to other shells, for example, do you want to be able to transfer moments or just normal forces? What should happen if there's a gap or an overlap, but it's in the contact region? Should it remove that or not? Do we want to allow separation? There's also breaking glue, so this is a simplified and this is a slightly more complex method to define how a glue connection can break. So we allow separation. Let's say you're physically modeling a glued joint, so some epoxy or something, you know there's certain strength, you want that to break at a certain load level. So that's what we can do with these settings. Okay, so again, as I said, we'll cover these forms in a lot more detail because every one of the settings on here is actually important. So that brings us to the end of today's session. So again, just to summarize, we briefly looked at contact algorithms and so on in the first, the basics of contact in Nastran and Marc, contact bodies and so on. In this, we spent a bit of time on contact table, what its purpose is, contact body pairs, which is almost the same thing, just slightly different way of looking at it. But then also we briefly touched on interactions and other settings. By this other settings, if I go back a slide, I refer to these settings. That's additional settings between two bodies. Okay, so in future sessions, we'll spend a lot more time on each of these and explain why each of those settings is required and when. Okay, so that brings us to the end of today. Thank you.